Okay, hello, how you doing? My name used to be Hernán Wilkinson, but now I'm, oh, come on, no, it doesn't work. What is the surprise? Ding! But now I'm Will Clippy. Thank you, Dr. Test. So we all know that Smalltalk is cool, right? We talked about that last Smalltalk at Salta. Everybody said, yeah, it's cool. And it's cool because it's dynamically typed. It's cool because it's a live environment. And of course, it has many more features we love about Smalltalk. But we all know that there is some missing information in the Smalltalk, sadly. And that missing information, besides other, is type information. We as programmers have to remember and we have to infer that type information every time we see a variable. Every time we see an object, we need to know, okay, what kind of object is this? Is a string? Is an integer? What messages can I send to it? And that information is not in the environment, unless it's running in a debugger or an inspector. But if you're working in a static tool like the browser, that information is not there, and you have to remember that. It takes time and energy from you, from us, all the time. So why don't we take that time and energy from the computer? That's why computers are for, to do things that we do all the time, repeatedly. So, for sure, you all know Brett Victor. He has a great talk called Inventing on a Principle. And there is a nice part where he says that we as programmers are used to play computers because we are used to run the system in our head and spend all that energy and time behaving as computer. So you know what? We do the same with types in Smalltalk. We used to play memory games with types when working with Smalltalk. And we should stop doing that. We have the computer to do it for us. So it's time to stop losing time and energy on that. It's time to stop getting invalid senders when you're looking for senders. It's time to stop getting invalid implementers when looking for implementers. It's time to stop fearing every time we do a rename. Doesn't make any sense right now at this time, to fear if we can do a rename, an automatic rename or not. It's time to stop getting invalid messages when you want to see with the autocomplete with messages you can send to an object. And I'm not saying stupid things. I mean, that's what other languages and IDEs, that I'm not going to say the word, but they have, and we don't. So it's time to admit that Smalltalk is not perfect. Yeah, sorry about that. Because if we don't admit that, we will not make it better. And that's very important. If we think that Smalltalk is perfect, we will never make it better. And Smalltalk was done in a moment in time. The people that created did a great, amazing job, but they took trade-off decisions when designing the language, because they had special hardware for that time. They couldn't do more stuff that for sure they thought, but they couldn't do it at that time, and they decided not to do it. And now we have better hardware, we have better virtual machines, and we're still using the same Smalltalk as in the 70s. So I think it's time to act and to change that. And that's what live typing is about, at least in a little part of all the things that we can improve in Smalltalk. Live typing is automatic type annotation that the VM does, and improvement in the tools to use that information and help us as programmers to have a better life. Wow. So, of course, this is not a new idea. We all know, we have been talking about this For a long time in the Smalltalk community, this is not something I created. This is not an idea that I came out in a day. It comes back to '86 on this paper. Dan Ingalls talks about this possibility. He says, oh, we could get type information and blah, 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 blah. We cannot forget David Angar's paper about pigs. They talk about it. They say we could use pig information to retrofit, the image, or in that case was self, with that type information and make it better. 2 years, 3 years ago, there's this great paper from Marcus Denker, Eric Tantera, and other guys in Chile about gradual typing for Smalltalk. So it's not new. And today I realize that there is a guy here sitting with us that in 2014, he said the same thing. Henrik Johansson, yeah, that guy over there. Yeah, just wave your hand. No? Well, and he said, types have an often overlooked purpose. I can reduce the number of false positives in common development actions such as autocomplete, searching for implementers, etc. And Faro with built-in type inference would be no better, but type inference with tools using it would make it better. So this is not new. But the good thing about light typing is it's not a new idea, but it's a particular one that works. And that's what I'm going to show. An important thing about live typing is that it's not about type checking, because that's where all the academic goes when they talk about types. Every time you see papers about types, they all care about how to help us not to make type mistakes, how to make the compiler tell you that you are doing a mistake, and that's not how we work with dynamically typed languages. We like to see a debugger open that does not understand to be able to program in the debugger. So I don't care if there is, for a moment, a type error. And I don't want to constrain the plus of small integer just to receive a number. I would like to send a measure. And if I want to do that, I cannot constrain the language with types as statically typed guys think. So live typing is not about that. That's not the main reason of live typing. We are starting to see now more and more statically typed information in languages like Ruby, like Python, and JavaScript with TypeScript, that they do all the same things as in a statically typed language. It's to help you with a compile a phrase and let you know if you're making a mistake and so on. But that's not what live typing is all about. The focus is on making our life easier when programming. So let's go to the examples. First of all, for sure you all know the tic-tac-toe. Oh, where is the mouse? Chang. Let me do this. Okay. Tic-tac-toe game, the tic-tac-toe, tateti. So I have an implementation of the tic-tac-toe here that uses an state pattern. This is the class that represents the tic-tac-toe, and this is the hierarchy of the different states the tic-tac-toe can have. Just to show you the example I'm going to show. So one of the main things about live typing is that you can see the types. You can see the types in the image. For example, here I can come here and say, okay, player X position is the type is order collection. Player O positions also the type is an order collection, and state has referenced objects that were instance of plane X, plane O, plane X1, player O1, and game tied, and all of them has a superclass tic-tac-toe state. We can see it that way. That was an idea of Pocho. Thank you, Pocho, for that idea. Or you can see it this way. It's the same idea with the advantage that if you click here, you go to the class and you can play with it. Also, there is an option to add new types or remove types because that's dynamic. So you may say, well, okay, but if I'm developing tic-tac-toe, I know the type of the objects, of the variables, so that doesn't give me too much information. Yeah, that's true if you have a good memory, but after 1 month, maybe you will forget, and it gets worse if you, come on, if you go to code that you didn't write, yes, like for example Morph, and you start looking, to some things that are called selector. Well, selector, okay, it's a symbol, but what about R1? What the hell is that? Okay, R1, okay, it doesn't fit in the screen, but it's a rectangle-like morph. Okay? So you get a better idea of what that object could be, and then you have delay time. So what do you think delay time is? It's duration, or something like that. Well, no, it's an integer, small integer. So those are the kind of things that are very useful when you're looking to code that you didn't write and you don't remember or you don't know the types of the objects. Thank you, Pocho, again. Autocompletion. How can live typing help us with autocompletion? So I have here var1 that right now I don't know the type because this code was never been run. So if I try to see what messages I can send to objects that are going to be referenced by that variable, if I press tab, I will see all these messages that for some reason are there. I don't need to explain that. And well, the nice things that we did in quiz is that if we are not sure if that object is going to answer that message, we put it in blue. And if we are sure that it's going to answer that message, we put it in black. And of course, all of these are in black because are implemented in object. So it's not really useful. But if we run the code, and now we see that var1 is a string, so the messages that I will see are only those implemented in a string and its superclasses. For example, find string. And I think about this is that because we know exactly which method is going to be executed when sending that message, we can show the documentation of the method and also the types of the parameters and the return type. So this is very useful when you want to understand how a message works, what is expecting, what is going to return, etc. Of course, doing live typing for having type information in a dynamically typed language is not as easy as in a statically typed language, because in a statically typed language, the type is just one. But in a dynamically typed language, types can be more than one, and they may not have any connection at all. So this is the example here. I don't know, maybe somebody could do this, but in this case, var2, the types are small integer and date. So it means that any, it could be any object that var2 is pointing to. So if I want to see the messages that are going to be answered by those kind of types, so we have plus that is implemented in timestamp and small integer. We have minus and so on. And we also have some that are in blue, like in this case, only is going to be answered only when that variable refers to small integer, and so on. So it helps you with that. And then, okay, we have this quiz that I showed the other day. So let me show you first how it works, how it used to work or how it works in most small talks. So if we have this collaboration and we want to see the valid messages that I can send right now, the only valid messages that I could send are the unary and binary messages of bar 1, that objects referenced by bar 1 can answer, and the keyword messages that the return type of equals knows how to answer. So how this works in current or previous quiz versions? Well, it shows me messages that are keyword messages for a string. Like, for example, find, well, the ones that you see here. Okay? And if I send this message, that's not going to work, because the receiver of output is going to be Boolean, a Boolean. Well, of course, output is implemented in object, but it's going to throw an exception, and okay, it's not correct. So now with live typing, what it shows are the binary and unary and binary messages of a string. Remember that this is a string, and remember that here we saw add, output, byte add, etc., that keyword messages, and now here we don't see them, because it's not possible to send those messages in this context. But we see, for example, if true is false, that are messages that are answered by a Boolean. So I don't know, I think it's a nice, that's how, when you start to see the power of live typing. Okay, dynamic types. Last year, when I was giving the first presentation about live typing, John Brani was here, and he asked me, what's the type of yourself? And he showed something that I didn't resolve correctly at that time, because yourself was saying that the type was object. But in this context, yourself should be examples. Okay? So if I see the autocompleter is going to show me only the messages that object knows how to answer. So that after that, I read the Marcus Denker paper about Graudel typing. They talk about dynamic types, and now that's how I took the idea of these dynamic types. Like, for example, self. If we look at the implementation of yourself and we try to see the type, it will show that the return type of yourself is self, and that's a dynamic type. It means that that type is going to be converted to the real type in the context that is used. So here it says self, but if I come here, it will say examples, because self in this context is example. So if I send the message class, so what's the type of class? So class is returns another dynamic type that is class, that is converted to the right type in the context that you use it. For example, in this case, the class of examples is examples class. So that allows us to see the real messages that example class knows how to answer, for example, create example, and not the messages that any class can answer. And of course, you can send the message new. If we look at implementers of new on behavior, we see that new returns instance as dynamic type, and that allows us then to see all the protocol of an instance of examples. So that's what dynamic types are. They allow us to get the real type in a specific context. And that's very useful for the autocompletion. Actual implementers. So let's see this message marked with X at. If I look at marked with X at, if I look for the implementers, for example here, normal implementers, we will get 5 implementers. But not all of them are part of the same hierarchy. We can see here the ones that are implemented in the tic-tac-toe state hierarchy, but also the one that is implemented in tic-tac-toe. So you could say, well, but they are polymorphic. Oh yeah, could be, but could be too also that the idea were, that they are not really polymorphic. So what actual implementer does is it returns the real implementers for the types of the receiver. So in this case, state, the types is tic-tac-toe state. So if I look for actual implementers, it will only return 4 instead of 5. That are those of, related to the tic-tac-toe state hierarchy. Okay? And if I look for the actual implementers of this message marked with XAT in this class, it will return me only one, that is the current method in this case. Of course, the same here, because the receiver is self, so if I look for actual implementers, it will show me only this method. So this helps a lot, because now you can, reduce the number of implementers that you have to look for, or you have to filter when looking for implementers. So the other day, no, not yet. So now, actual senders. Sorry. What actual senders are? Well, the same idea, but for senders. So if I look for senders of marked with XAT, I get 7. But not all of these senders are going to evaluate the same method. Are not for this. They are not really polymorphic. So one of them is sent from here, and another one is sent from here. And then we have all these tests that are also sending that message. But if I really want to know the senders for only this method, I can do actual senders. And instead of 8, it will show me 7 in this case. And there is one interesting thing here. In this method, we have the same message marked with XAT, sent in 2 different places. But it's not really for the same object. Here is sent to state, and here is sent to self. And because they are not of the same type, it doesn't mark this message send as the actual message send. Does it make sense, what I'm saying? Yes? So it shows the real message sends. The senders, we're used to relate senders with methods in Smalltalk, but that's not correct. Senders should be real message sends. So right now we're seeing the real message sends, not the methods. And if we look for actual senders, in this case, where the type is tic-tac-toe state, I will get only one, and not all the others. So you don't have to spend time filtering all the other senders. So okay, so now yes, like, the other day Facundo was giving a great presentation about how to travel SAT, and he showed that he was going to visit a message node, and Leandro said, why the message node and not the selector? And we said, oh, well, maybe you don't know exactly where you're going to visit a selector and so on. So we had that thing that, oh, come on. Okay, so this was the code. And so how can I know all the places where accept is sent to instances of selector node? So in a common Smalltalk, the only tool you have is senders. So if we look for sender of accept, well, you know, there are a lot, 49. It's very difficult to, you know, infer if only that message is sent from these places. But if we do actual senders, so we got 21, is better than 49, and we can see that all those accepts are sent from a visit message node, but this one, but that's okay. But then we can deduce, oh yeah, so only the accept is sent from a visit message node. And now we see here what is possible senders. Possible senders are those senders that live typing is not sure if they are actual senders or not. And in this case, all these possible senders is because Ines didn't finish his tip. Sorry. No, because the message accept is being sent to statement, and statement is a parameter of a block. And we don't support yet types for parameters of a block or variables of a block. So those are all the possible senders. If we could have that, we will get only these 7 places, and it would be great. So now that we have actual senders and actual implementers, we can start using that information to do refactorings, for example, a rename. So if I want to rename, let's say, I want to rename Mark with X at. So if I do a rename, well, Quiz will ask me, where? What's the scope? There is, you have to select the scope of the rename. So if I say, well, okay, let's try that in the category, the class category, it will show me, okay, you have all these implementers, and then I have to look to them, and I don't want to rename this one. I want to rename only the ones on the hierarchy of tic-tac-toe stage. So I have to remove it, and then I have to look all the senders, and okay, this is not the one I want to rename. I don't want to rename this sender, and I have to do this by hand. But with actual senders and implementers, if I do a rename, I can select now actual scope. And actual scope will only show me the actual implementers and the actual senders. And look at this. This is very important, because in this method, I'm sending the message mark with X at in 2 different places. But only this one is the one I want to rename, and not this one, because that is being sent to objects of other type. So let's do the refactoring, and now we can see that only this one was renamed and not that one. The same thing is for all the other related refactorings, like add parameter, remove parameter, and so on. So I think that's very useful. Finally, what all want to see, I guess everybody wants to see type checking. Yeah. I have to write a paper about this now. So I implemented a type checker that allows you to type check your code. For example, here I have IV1, the types are small integer, and this is an interesting thing, because I know that nil was really assigned to that variable. I can say, be careful, this object could be referencing nil. So now if I type check this method, it will show me, hey, you have 2 type errors. Oops, sorry. The first one says that date is not implemented in a small integer and undefined object, and that's true. So I will change it with print string, I don't know. So it goes away. And now a factorial is not implemented in undefined object. So, okay, let's do nice stuff. If not nil, IV1 factorial. Yes? And it goes away. So, you can start doing this stuff, and the nice thing is that it doesn't interfere when you are programming. You do it when you want. And of course, doing a type checker for a dynamically typed language is not easy, because it's very common to have this kind of if-nil stuff. For example, here, okay, I'm using a temporary variable to show you the possible types of that variable, but this, what I'm going to show, works for a temporary variable, instance variable, message 10, and whatever, okay? What I'm trying to say is, don't think that I'm just doing type checking because I know here that nil and 1 were assigned to this variable. So if I type check this, it will tell me plus is not implemented in undefined object. So I can do another ugly stuff, like, okay, temp1, if nil, get out of here. Yes, this is very common. So what the type checker will do is he will realize that from here on, type 1 is not nil anymore. So if I type check it, it will tell me, okay, that works. And we have many other things like that. For example, or. Temp 1 could be nil or a small integer. So if it's nil, or if it's not nil, temp 1 odd. So this is only be sent if temp 1 is a small integer and it type checks correctly. We can have nested if nils, and the same with if not nil, and all those kind of things. But let's get to the most interesting part, is kind of. So here we have temp 1 could be a small integer, an ordered collection, or a linked list collection. So if temp 1 is kind of collection, then I will send the message at last that is implemented in these two, in the hierarchy collection. And of course, this will type check. Okay? So if I remove this, it won't. Yes? Okay? Does it make sense, what I'm showing? Okay. The same thing with asking for the class of an object. If temp1 is a small integer, then do this. If not, do that. And again, it knows from here on that temp1 is not a small integer. That's why it can send the message first to temp1. And it type checks. Something that we have to improve is if I get here and I see for the types of temp1, it's still showing me both string and small integer, but it should show only string, because it knows that at this moment it will only be string. The same thing with the famous hash model. Yes? Let's see, temp1 could be nil, morph, pluggable morph. So if it's not nil, but hash model, and what is hash model? So let's see implementer of hash model. It returns false in morph, but true in pluggable morph, and all its subclasses. So what the type checker does is it looks for the actual implementers of hash model, and it checks for the types, return types of those of that message, and then he filters the types based on that. And this is an interesting thing. Also, hash model is the return type is true. It's not Boolean. And the return type of hash model in morph is false. It's not Boolean. So that helps a lot because you have more concrete type information. And the same thing for, I don't know, is collection, is number, and so on. Okay. Oh yeah, this is a very nice example. Let's check. Let's type check morph. I don't know why. Okay. So let's type check morph. What do you say? It's going to give some type errors or not? Let's bet. No, of course not. But oh yeah, it does. For example, at from. At from is sending the message first submorph to owner, and owner can be nil. You could say, well, but at from, maybe every time you send the message at from, you are sure that it's not nil, so let's look for actual senders. Okay, and you have to be sure that it's not nil, but, you know, I don't know. I wouldn't be sure if somebody changes or somebody uses at from other place and owner is nil, you will get an error. And, well, it has, most of the errors are because of that. The same thing, because owner could be nil. And what about behavior? That's another one. Behavior. Can have behavior type check errors? No, of course not. I mean, it's from the 80s. It works. It's been working for more than 40 years, but it does. For example, here, it's sending the message, the non-meta class, but non-meta class is not implemented in behavior. So, in this case, you could implement non-meta class in behavior as subclass responsibility. That's what you should do. Yes or not? Yes. Yes. So the same thing, well, this is an interesting one. Superclass can be nil. So if you send all class var names when superclass is nil, it's not going to work. And, well, so on. There are many things like that that, no, they don't happen, but they could. So, and now, after ISUG, we spent some time with Pablo and with Guille, and I really want live typing to be used in Smalltalk. I'm using Quiz because I think Quiz is great. It's easy. It was very easy to implement this in Quiz. Wasn't that easy in Faro, but we make it work. So now there is a small implementation in. Why does it look so ugly? Okay, here it is. So right now we have a VM in Faro that annotates the types. So I can see the types of start in date or the types of duration in date. Here in customer, for example, there are no types because I never send the messages to get those, to do something with customers. So now I'm going to create a customer. Alan Kay is a customer of mine. I don't know if you knew. So now that I created a customer, I can see that first name, the type is cool, nothing. What happened? A customer. Woo, it's not working. Well, that's weird. Wow. Well, I don't know. It should say string. I tried, I don't know what's going on. So anyway, but it's working. As you can see. I don't know how much time I have. I can restart Faro, but I think it doesn't make sense. It works, okay? There are some tests that are not passing. Most of them are related to UI stuff or special stuff. So it would be great to have some money to spend on this and make it work. Okay, conclusion. With no X34, we were able to get rid of all these advantages that we talked at the beginning. And the cool thing is that we don't have to maintain those things. Types are maintained by the computer. I mean, you have nothing more to do that you actually do. And I think it's a nice solution because it doesn't interfere with the code that you read. Live typing makes types explicit. You don't have to remember or infer types anymore. And it's a very simple technique. It's simple, and I think it heavily improves the programming experience. It doesn't change the syntax. It doesn't stop you from compiling. It does not force you to use it. And types are not in the source code. And I think that's great because they're real objects and they are treated as objects. So I humbly believe that live typing respects and honors the Smalltalk spirit. So at ISUG, James Foster asked me, why are you doing this? What's your goal? Right? Wow, I never thought about it. I like doing it. So after that question, I realized my goal. Well, I think that my goal right now that I thought about it, is that to stop saying that Smalltalk is dynamically typed and start saying that it's lively type. And I think that will make a big difference with other dynamically typed languages. Okay, so future work. Well, Ines is working on making types for closures, for parameters and variables and closures, support for parameterized types or generics for collections. Also to implement this on the JIT VM, because right now it works only on the stack VM. And there are many, many ideas that, every time I use it, I come out with new ideas, like, for example, there are more typecast for the type checker I have to implement. A way to say I want to freeze the parameter types of this message to be able to type check also parameters, to improve the type checker when you, the autocomplete to use the type information for the parameters to use that information to see what objects you can send as parameters. Also, we can use DVM in production to get all the type information. If you don't have tests on development, retrofit that type information in your development environment and use that in the development environment. We could use the type checker to warn about that code. I don't know, many things. So you can download it from here, and that's all. Thanks. Are there any questions? Yes.
So I'm glad that you took my suggestion. Thank you for the grades. So now maybe it's more than a question, maybe it's another suggestion.
Yes.
But maybe you thought about it previously. In the example that you showed that you have a variable that is assigned many times,
yes.
Right? You continue to see in the end that the variable can have different types, and actually it doesn't. It have one type at one moment and one different type next. So I'm wondering about the internal model for representing the variables in the type checker, and you probably know that there is this representation of code which is called static single assignment, where each variable is assigned only once in all the code. So if you have a variable that is assigned many times, you basically create new versions of it, and then if you make in your model a representation of variables in that way, then you have no problem, because you know that at the end you have, for example, here temp1, which is the second version of temp1.
Yeah.
So you can type check it very
but
easily.
Remember, this is a dumb example. That would work only for temporary variables. It's more difficult for instance variables, and it won't work for message sense.
Okay.
Yes, but it's true. I mean, I could do that. I'm not doing it because I'm just checking the types and the messages. And it's very simple type checker. But yeah, some things like that could be improved in the type checker. Yes.
Two small questions. The first one, the semantic of super is respected in the self-type?
Yes.
Perfect.
Yes.
And the second question, what is the lifetime of the information? Because during development, maybe I make a mistake and I assign something wrong.
Yeah, that's a good question. Right now, what I'm doing is resetting the types every time you, for example, in a method, every time you change the method, all the types go away. We tried at the beginning keeping the types, and we could have both strategies, but right now the types go away when you change the method. Regarding, so that will reset the types for the return type, the parameters, and the local variables. And regarding instance variables, they go away every time you change the shape of the class. That's how it works right now, but could be different strategies. And also you have the opportunity to reset the types of the whole class or a method, or you can come here and if you say, I don't know, I made a mistake, oh yeah, it cannot be nil anymore, so I will remove undefined object, and now it's only small integer. So, but when I mention that, I'm thinking about saying, I want to freeze the types on this parameter or this return type of the message, that is to avoid those kind of mistakes. Yes.
So, in your experience, because the types you get are the ones that were exercised when there was a method, an actual send from, for instance, from a test.
Yes.
Right. So maybe in another flow of the execution, you get something that wasn't captured yet.
That's right.
So my question is, in your experience, this happens very often? Is a problem?
No, not really, because, well, it depends on how you work. But it depends if you are testing your work or not. If you are doing TDD, it won't happen, because it's supposed to be everything tested. But we don't all of us work with TDD, and but if you test what you're doing, you will get. I mean, I never saw a variable with a missing type that was important, or that I realized, oh no, this variable is missing this type, and so on. I never saw that. But of course that it could happen. But the truth is, it's not a perfect solution, you know, because if you think about this, it's not perfect, you know, it's just a cache. So the contents of the cache will depend on how you, but the truth is, it's like polymorphism. You know, we have polymorphism for all the messages, but we only really use it for 40, 50, and most of them are not polymorphic, so same thing happens here. It's good enough. It's great good enough.
And the other question is, if you implemented this also for shared or global variables?
Yes. Yeah, but in that case, so no, let me think a little bit. Yeah, in that case will work. Yeah, no problem. Yeah, because a global variable already has a type. So I didn't have to change anything on the VM for that. So when you see, let's say if I type smalltalk, and I come here, it says system dictionary because it knows that smalltalk is system dictionary. So there's nothing special from the VM point of view to know that type information. Yeah.
Okay. No more questions? Okay.
Okay, thank you. Oh. So, yeah, they gave me the responsibility to end the conference. I thought it was not a good idea because I was the last talking, but anyway, so now I'm not Will Clippy, I'm Hernán Wilkinson. So, well, thank you everybody for coming. Thank you for the local organizers. You did a great job. I think as I told you, I think this time we got the best food of all the small talks we had in 13 years in the break, you know, with vegetables, and you know, the food was great. Thank you to all the sponsors for helping with this. It's very important to keep us alive. And well, thank you, all of you for coming, and I hope you enjoyed and had a good time. And next year it's going to be in Buenos Aires. Yes?
No, no way.
So, see you next year. Bye.